All right, I think we are ready to go. Thank you everyone for being here. My name is Bhushan Gupta. I'm one of the members of PNSQC board. And just to let you know, I've been with PNSQ since 1998. And I'll have a wonderful prize for somebody who can guess how long PNSQC has been in business, for how many years. Let's see.
Keep going.
Keep going, keep going. How long has PNSQC been in business?
Anybody else? Yes.
47.
Go up. Go up. 40 years, that's right. We are selling our 40th anniversary this year, and we are very excited. I also want to thank our sponsors, NIC of Oregon and Tyler Technologies, who have graciously given this opportunity to put this meetup together. I just want to take you back to PNSQC, give you a little bit more ideas how you can be helpful, how can you support, how can you participate. So, Cody, can you bring up my slide deck, please? All right, so we have our big, huge conference from October 10th to 12th. It's a 3-day event. We have technical presentations for the first 2 days, and the third day is training day, where we have workshops, and our workshop are very in different areas. There are different areas we do workshops. Very good. So we already established that we have been in business for 40 years. It's a totally voluntary organization. Nobody gets paid, nobody is benefited. You'll be part of it, but there are a bunch of benefits you'll get. First of all, the network, and we'll go do some more of that. We focus on quality. People who participate in that conference are practitioners. We also welcome those who are new, they want to participate in a conference, and then new concepts and technologies, we really focus on that too. So we are really addressing all aspects, pretty much all aspects of software quality. Like I said, speakers bring their own concepts, own experiences. How can you help? First of all, you can write blogs. You have some expertise, you have had some experience, you can write blogs for us. You can be a paper reviewer. This is the only conference at this point I know of where the papers are peer reviewed. And we are very conscientious of keeping the quality of the papers. That's very important to us. You can help out with sponsorships. You can help out organizing events like this. And you can also be a sponsor if you want. There's also positions on the board. There are other activities you can participate in. There are so many ways to help out this volunteer organization. What I have gained from PNSQC is camaraderie. Just made friends. Everybody comes on his own. I was on my own in 1998, and made so many friends. I'm still with those people. I know them very well. You can be an author. We really support people who are new. We really provide all kinds of support they need. It's a experience with networking, speaking, and you can. I have presented to huge group of people, so it just gives you an experience to do things in a public setting. All right, so I talked about you can write technical papers, workshops, keynote, we do everything. This year, we are soliciting abstracts until May 9th. We normally get over 100 proposals. Out of those, we select 37. Our workshops are handpicked. Our keynote speakers are handpicked. So it's a great place to be attached, associated with, and get what you want. Again, the conference is from October 10th to 12th, and I hope to see you there. Thank you. And the prize. Oh, okay. And the prize goes to Suzanne.
Hi, everyone. I'm Ying-Ki Kwong. I work for the state of Oregon in the Enterprise Information Services area of the state. I'm responsible for the state's e-government program and statewide QA program. I'm very happy to be here today to introduce our speaker and to give a little bit of introductory remarks about the topics of today, which has to do with licensing systems. I'm also a board member of Pacific Northwest Software Quality Conference. So on behalf of both the state of Oregon and the PNSQC, I welcome all of you that are in our venue in Salem, Oregon, as well as in cyberspace. Some 50 of you signed up for today, and we will make available the presentation today online, a video recording, as well as the slides that are used. We look forward to make that available to you on a web page of the PNSQC. With that said, I'm going to very quickly talk about my own experience in having oversighted various licensing solutions being implemented in the state's licensing boards and commissions and agencies. From my point of view, typically licensing systems have certain basic feature functions that are needed to enable the work of licensing professionals, licensing and permitting of specific activities and services. And in the process of doing that, of course, there's various workflows that require standardization and automation. And these typically ranges from the initial application process and then the typically annual or other cycles of renewals. There is a need to take in payments and do accounting associated with fees payment, as well as fines and other types of payments. There is the enforcement and inspection aspects, as well as taking in complaints. And when a professional is subjected to discipline, including loss of licensure, there's also appeal processes. These are typically the workflow that needs to be supported in these licensing systems. With many, many business rules, many of them are traceable to administrative rules, agencies, or even statutes. So I think the importance of being able to configure business rules without a lot of coding by agency business staff would be very important. As is the security around personal data. Many licensing systems, of course, contain some very personal information about individuals, personal identifiable information, as well as even more sensitive information, folks' background checks and things like that. There is, of course, a need to support management decision-making through searchers' reports, as well as support of the licensed communities. Last but not least, most of these systems require professional services around hosting and applications support during their usable life. So I think one way to think about the future and the evolution of licensing system would be around how well integrated these features are for ease of use and ease of support and maintenance, of course. Increasingly, the state of Oregon, as well as many large organizations, are looking at deploying secure solution in cloud-based infrastructure. There's a commercial cloud, there's GovCloud for different types of needs. So I think it goes without saying that the future will see more deployment of these type of secure system in cloud with hopefully very easy to use without a lot of coding to reconfigure business rules. With that as a background, I'd like to introduce today's speaker from Tyler Technologies, Mohammed Dessouky. He's joining us remotely using Zoom from North Carolina. So we are very happy to have him to tell us about these different aspects of kind of today's modern enterprise system, especially as it relates to licensing of professionals and other needs. I now turn the floor over to our speaker remotely.
Thanks, Ying. I appreciate it. All right, let me share my screen real quick here. All righty, great. Get the slide deck going. So good afternoon or good morning, everybody. It's certainly afternoon over here on the East Coast. I'm really happy to be here. Really appreciate the opportunity. I prepared this little presentation to talk about monoliths and microservices, and I think that's it's not unique to us. We didn't invent anything here, but it's very near and dear to us, this journey from monoliths to microservices. And it's really special to me because I've been before it was Tyler, I was with a small little company called Versa, which was acquired by another company called Iron Data, which was then merged with a company called Micropact, which was acquired by Tyler. The journey's long, but I've been working in the regulatory space, I would say, since 2003. So it's been a lifetime. I mean, certainly my kid's lifetime, that's for sure. So it's quite near and dear to me. So our software stack as it stands today looks nothing like the software stack when I joined Versa that we were using to deliver solutions to state regulatory agencies. So just for the benefit of everybody here, and you know, Ying touched on it, and I'll go very quickly. You know, state regulatory systems, like what do we cover? What's our area? What is the breadth of what our software stack covers? And our core is professional occupational licensing. So those agencies and those boards that, you know, manage real estate, whether it's appraisers, agents, etc., salespeople. Timeshare is becoming a big thing with real estate agencies now, cosmetology, etc. Any professional occupational licensing and regulation is our core. But our application can also be used for alcohol and the regulation of alcohol, production, etc. Public facilities, healthcare facilities, hotels, businesses. It can be used for dispensaries and taxis, cannabis, controlled substances, etc. The regulation of distributors, the regulation of retail outlets, etc. Social services, it's very broad. Banking, securities, public utilities. It's very, very broad, but it's one application suite that has to handle that all. And so Ying touched on it when he talked about configurability, and that's truly what is at the heart, or what makes our solution as powerful as it is how configurable it is, but also scalability. Scalability is very important. So I'll give you guys an example of one of our typical agencies. So this is a customer we have in California. It's Department of Consumer Affairs. So our system handles about just under 3.5 million licensees. We're handling about 500,000 applications a year. About 1.5 million renewals. There's about 37 boards. It's very diverse, it's very broad, and it's very large volume that we have to handle. So not only is there the complexity of the configuration, but there's also the complexity of scalability, et cetera, and whatnot. And so our solution has had to evolve over time. Over that very first install we got, our solution dates way back to, wow, before me, 90s. It was a green screen Informix 4GL solution, and we've come a very long way to where we are now, where it's basically a full stack on a platform, cloud, delivered over cloud, multi-tier, micro app, you know, based architecture that we have now. We didn't get there in a day. Rome was never built in a day. But that journey from monolith to microservices we were a part of it. It was a big part of what we do. So, you know, monoliths. I think that's how it started, and that's how it's going. Everyone's abandoning ship. Titanic. This meme probably dates me a little bit. That's the villain. He was abandoning the ship before it sunk when it hit the iceberg. It was escaping with the women and children. But I mean, that's when I think of monoliths, I tend to think of these very large Titanic-like software structures, and I'll define and talk a little bit about what a monolith is. But ultimately, what sinks them? I mean, why did they change? I mean, monoliths serve a purpose. I mean, they're not entirely extinct. They're certainly extinct for very large, or they're becoming extinct for very, very large, complex software solutions. And the reason for that is because software is dominating pretty much all business and the whole world, really, in terms of what businesses do. And in order to survive in that world, businesses have to innovate faster, okay? And in order to innovate faster, you need to deliver and build software more rapidly, frequently, and reliably. So more rapid, frequent, reliable delivery. And that is the underpinnings behind why architectures evolve the way they do for things like monoliths to microservices. Monolithic architect, this is an architectural principle, monolith versus microservices. And the way it's measured, the way we measure rapid, frequent, reliable deliveries, we measure it by talking about velocity and reliability. Velocity is how, it's two things. It's your lead time, which is the time it takes from when a developer commits to when code is deployed. And it's deployment frequency, how many deploys per developer per day. These are, very objective measures. Reliability is measured by mean time to recovery, which is about how long it takes when a deployment fails to recover from that. And then change failure rate, which is about the percentage of deployments that actually will cause an outage. And these are just objective measures that are used to measure success of, software meeting those goals, if you will. So let's talk about what is slow, what is better, what is fast. All right. Slow is you're doing deployment frequency once a month. Okay. Fast is you're doing it on demand, where you're doing multiple a day. The lead time in slow from committing to deployment can be a month. The lead time in fast can be less than an hour. Mean time to recover for a slow is maybe a week. It can take a week sometimes to recover from an outage. Fast, less than an hour. Change failure rates. We're going from 45% to less than 15%. And so staggering changes in performance and improvement between slow and fast. This is data that's based off of a survey that was taken by DevOps report summary back in 2018, and it's gotten much better now. But that just tells you the scale of between fast and slow and organizations and how they do what they do. So I'll just give you guys an example of fastest. Okay, these are like the champions of the industry, if you will. So in Amazon, they have the ability to deploy in 11.6 seconds per developer per day. That's their average. The lead time from commit to deployment at Netflix, on average, 16 minutes. In Amazon, the change failure rate is less than 0.1%. So clearly, these guys are the dominant players of where they exist. But it also shows you the bar that we're chasing, or that's been set about expectations around rapid, frequent, reliable delivery. So now that we understand what the goal is, let's take a step back a little bit and talk about what a monolith is. And I assume everybody is vaguely familiar with it, but for those that aren't, I'll walk you through that step. So a monolith is basically when all the modules or all the subsystems or all the components, all the parts of an application are interconnected into one single self-contained unit. Titanic, just this one giant piece of code. All the code exists in one code base. And the entire application is basically deployed at the exact same time. And the way you scale is you add nodes. That's how you achieve scalability with monoliths. So you can see how it's limited in its definition. So what are microservices? Microservices are when services are organized around specific business functionality. And sometimes you'll hear me refer to micro apps and microservices. For the purposes of the discussion, we will treat them as one. the nuance is a little bit around micro apps tend to have a UI, services don't have that, but for the purposes of the discussion, same concept, same ideas, same everything. So whether I say micro apps, microservices, what they are is they're highly maintainable and testable, which means minimum lead time and high deployment and high rate of deployment and frequency, which are some of the measurements that we use for achieving success in delivering high quality software. They're very loosely coupled. They're not tightly integrated with each other. They're independent and they're independently deployable. And they usually have a very small team that develops them, maintains them, and operates them. So those are the attributes of what a microservice is or what a micro app is. In our world, our regulatory monolith, and it's interesting. I actually hadn't seen Ying's slide before he presented it today, but you can see the correlation between what he spoke of and our software stack. So our regulatory monolith had what we called subsystems. Now our code was organized. I'm not saying our code was spaghetti code. It was very organized. It was packaged. It was structured in a way, but the pieces of the software that dealt with the application process and the issuing of a license, that dealt with the inspection process that had to happen as part of that issuing, the continuing education tracking of the licensure and all the rules that drove continuing education requirements by the different license types, the enforcement, when a complaint was filed and the case that would follow, the investigation into the complaint, the intake of the cases, the central cash management system that would have to map to the state accounting system. A lot of times, all those complex pieces were this one big piece of code. It was about I think it was like just under 1.5 million lines of code. And it was all this one giant app that did it all. It had a portal and a back office, but it was all this one giant app that did it all. And so what we've been doing is we've evolved it now. Now it's multiple. It's a suite. It's actually a suite. And there are these decoupled applications where we broke out that specific functionality into these specific pieces. So we have an app for licensing that focuses just on the application intake and licensing process, separate from our application that focuses on the enforcement things that happen around licensing. Because ultimately, why does government give you a license to begin with? So that they can take it away when you do something wrong. And that's what enforcement is. And so that is its own app. It has its own UI, its own database, etc. And this is how we've been evolving our solution. And it's served us well. It's served us not just in our ability to deliver quickly, but it's also served us in our ability to open up different markets and new markets for us. We could never before go and sell an enforcement-based application to an agency without them also using our licensing system and using our cache module. And because we've started to think differently about, how we can scale better and have a quicker to market features, we're now actually opening up additional markets for ourselves where we can actually go to an agency and install our application for enforcement on a back office that isn't necessarily ours because of the paradigm we used when we were building and delivering and developing it. So great evolution really of our stack. It was really great. And so just real quick, for folks to understand, and I apologize if this is a little technical, but just so people understand, when we talk about a microservice, what's the structure of a microservice? What makes it what it is? Well, first you have to talk about the operations, how other software components or microservices interact with it. And those operations they can be commands and they can be queues. Commands tend to be synchronous, queues are asynchronous. Synchronous is where I make a request and I can't move on until you respond. Asynchronous is sort of like sending an email. I don't have to wait till you read the email before I carry on with my life. So API clients, that's where the microservice makes calls to external microservices to invoke, whatever functionality is required. And then events, whether it's publishing of events or subscription of events. And that's kind of how a microservice interacts with the world. It's a very controlled frame model, but more important is the fact that a microservice usually has its own data store and it's private and it's not exposed to the world. And I'll talk about that some more when I talk about the various patterns of what's going on. So that's what a microservice is. Okay. So we talked about what a monolith is, what microservices are. So why what's wrong with monoliths? What makes them as bad as what they are? Or makes them what dates them to what the expectations are around delivering quality in an expedient manner. So starting with the development stack. In the world of monoliths, you basically have, in the monolithic architecture, developers don't have that freedom where they can choose whatever programming language they want or storage solution for the services that they're writing. So why is that a problem? Because as your application grows, as ours did, when we started off, we were not doing all those little shapes I showed you guys. We started off, it was just a licensing app where it took in an application and issued a license. It didn't have all those pieces. So as we started to grow the solution, what ended up happening is you have more diverse data and data sets and different ways of dealing with those types of services that you need. And that usually, has different processing requirements. But when you're on one dev stack with a monolith, you're stuck with that one dev stack. You can't address that diversity in the way you need to. On the other hand, because microservices are loosely coupled and they're built almost independently and they're deployed independently of each other, you can choose different technology stacks for each of the various services, because ultimately it's the interface that between them that matters, that you have to stay true to and maintain a contract with. And this gives a ton of flexibility and lets developers choose the best programming language, storage solution, for the particular service that they're building and operating. Understandability. Because microservices are smaller in size and scope than the monolith, it's easier to train and onboard people. It's a much smoother experience when you're going out and bringing in new hires. It's a much smoother experience for your trainers. Services, each microservice or micro app has its own dedicated team, so they're focused exclusively on that. Because it's so specialized, you don't have to learn the ins and outs of, and the interdependencies, where in a monolith you do. You have to understand the entire monolithic application and architecture really to be able to maneuver it and move your way around, because it's more complicated. So you've got an understandability problem. So you've got a development stack problem, you've got an understandability problem, you have resiliency, fault tolerance, and isolation issues. The tight coupling that comes with one code base, one stack, and low cohesion. At any time you make a change to a monolith, you introduce a great deal of risk. And those of you in quality control know all about risk management, when you're introducing software changes. So in a monolith, every change is a very high risk change because it's a single unit with a lot of interdependencies. One bug in one tiny area can affect, for one feature, can affect completely unrelated, uncorrelated areas of the entire application. So they're a lot more of a nightmare to test and to even roll features out with. It's just any kind of change is a nightmare with monoliths, as opposed to when you break it down and be more targeted in what you do. So because of all these faults, it's also very hard to find the root cause of a problem. So it would be great if there was a problem and the stack trace just told you where to go to fix the problem. It's not always that straightforward, is it? Those that are in the development world and in the QA world, like the stack trace doesn't always tell you the full story of what's going on. So it's a lot harder with a monolith to triangulate and narrow down where the issues are. Not to mention, it's very difficult to recover from because even once it's been isolated and you've resolved it, you have to rebuild and deploy the entire monolith. You don't just target the area that's broken to fix what's going on. So microservices, because of their loose coupling nature, they obviously don't have these issues. They take care of these problems architecturally. We've eliminated these problems by re-architecting the solution. Deployments are time consuming because it's so large. And when a deployment is time consuming, certainly for in the world where everything is moving to the cloud and people are expecting features to be rolled out constantly all the time, and your deployment times are time consuming, you are limiting how often you can go to market with new features and advances and whatnot. And that's problematic for monoliths. So they don't really map to the cloud-based world of constantly pushing out evolution to your customers, where your customers are just consuming the service, which is what we're starting to do now with our state regulatory app. And then layer on top of that, So microservices are designed for rapid deployment, but with smaller dedicated teams. And you don't have to worry about the impact of what you're deploying in other areas because of the way it's designed in an isolated nature. And then when you layer on top of that things like Agile, DevOps, CI/CD to the processes and whatnot, it comes together even better. So it's more than just architecture, and I'll talk a little bit about that as well. But deployment is a big area where there's improvement through this architectural change. And there's a lot of other challenges too. Scalability, declining quality control of code, related to some of the things I talk about, but also related to a lot of other things, lack of flexibility. When you have such large teams, they're much more complicated to manage, and it's more flexible. You're stuck with traditional methodologies, which won't work with the micro app, microservice architectural approach. So those are everything that's wrong with monoliths, and the list is obviously big. And it's not, it's a deterrent. They are a deterrent to successfully, evolving into a cloud-based architecture for a very large, complex software system. They truly are. But what's wrong with microservices? I don't think we can talk about microservices and micro apps without talking about, what's wrong with those as well, because I don't think it's a perfect world. I think the biggest drawback of microservices, in a word, is complexity around development, testing, deployment. With development, you have inter-process communication overhead, partial fails, distributed data challenges. With testing, you've got much more complicated integration testing, end-to-end testing being such an important part of what's going on. Testing complexity gets a lot more. And deployment has its challenges as well. There's lots of questions microservices raise. How do you decompose an application? How do you deploy an application services? Which communication mechanisms do you use? The list is very, very long, but microservices add complexity. The architecture approach certainly does bring complexity, and that's a drawback, probably one of the biggest drawbacks of microservices. But also, it's challenging to implement a feature that runs across all the services. So whenever you need to make a change, that is like, so for us, whenever we needed to make a change to something related to our entity model, which spans across the application micro app, the enforcement micro app, and the cache micro app, because all of them deal with our entity model. Oh, by the way, these are our Scrum teams. These are our sprint teams, Chuck Norris, Deadpool. This is just an example of, these are the sprint teams. These are the areas of the system they're responsible for. When there's change across all of them, you can run into problems from a design and planning perspective. It requires a lot more coordination across the teams. If it happens frequently, you really don't have a micro app architecture. You're really just dealing with the distributed monolith. And if that's the case, you probably should reconsider your decomposition. But that's something to watch out for when you move in that direction towards that architecture. There's also a lot of published anti-patterns, a lot of really good anti-patterns that surmise what's going on from a technical and not so technical perspective with regards to microservices and the obstacles they bring, and the whole approach of decomposing, the obstacles that brings to your ability to test, your ability to deploy and deliver rapidly. Can't have a slide deck without Dilbert. So technically, let's talk a little bit about the technical anti-patterns. So one of them, distribution is free. What is that? That's basically where developers treat a service as if they are programming language level modules. So they're basically like, they treat a service like it's an API call, and there's lots of HTTP communication. This results in high latency. Inter-process communication is very expensive with high latency. It's synchronous communication. The tight synchronous communication leads to coupling, temporal coupling, and then obviously that reduces availability. So that's a problem. Distribution is free. What's the solution? You have to really carefully design your interaction, design carefully. Consider how your services interact, make those interactions more coarse-grained, make them asynchronous where you can as much as possible. Self-contained services, where there is synchronicity required, consider how you can bundle those services together rather than waiting for responses from other services. So that's one way to tackle it. A shared database. This is a very common problem. It's basically when multiple services are all trying to update the same table, or they're dealing with the same, manipulating the same table in multiple ways. And this basically makes it impossible to have microservice isolation. So you start to violate some of the fundamentals because you can't isolate at runtime. And then now all of a sudden you can't isolate at many different layers as well, not just at runtime. And the solution to that is one database per service. I think at the beginning, when I was defining what a microservice is, at the very end, microservices usually have their own data store and it's not shared. And whenever services need to communicate with each other, they will never go directly to the data store of another service. They will talk through the services interface to communicate with the data store. Unencapsulated service. I mean, this one's pretty self-evident. This is a little piece of code there. I genericized it, but if any of you have looked at code or seen code, you'll understand that a service that has a large API basically encapsulates very little. So if I remember one of our very first services that we wrote when this was before REST API and whatnot. We were building RPC. And we wrote this one service that took something like 20 parameters that was doing initial application intake. And it was such a mess to maintain because the API is frequently changing. And so you are forcing incompatibility with the consumers of that service and their ability to upgrade. And it basically defeats the whole purpose of microservices. So encapsulation is key. There is a pattern called the iceberg services. It's funny that it's called that. That's not the reason I came up with it. I stole that Titanic meme. But basically, it's all what encapsulation services say. The concept behind the iceberg services is that the service API, which is at the very top, this is the water level. It looks like a mustache. This is the water level. The API at the very top is very, very small. That's all you expose, very little. And then the implementation or the services behind that API can be very, very large, of course, with their own data store. And ultimately, the goal is bundle the data, bundle the behavior as much as possible. But that's how you overcome that pattern. It's just do more encapsulation. A distributed monolith. That's another problem. I touched on it a little earlier too. That's where you have two or more services that implement the same concept. They solve the same business problem. And why is that a problem? Because now if the business needs change, if there's legislative changes, there's new rules, you have to introduce new code to manage whatever, they have to change in lockstep. So it's duplication. It's not so great. So you can see how, it challenges, one of the key concepts of cohesion. There's two principles in cohesion. Sorry, there's two components that have two types of principles and how they interrelate: cohesion and coupling. The common closure principle deals with the cohesion side of it. It basically says that things that change together should be packaged together. So that's the underlying principle there about the distributed monolith. Things that need to change together should be packaged together. If they're packaged separately, they shouldn't need to change together. So that's one solution. It's apply that CCP. You understand the domain and how it evolves. This is easier said than done. It usually requires a crystal ball, which none of us have, but you can learn from the past. So you really just let history guide you with regards to what's happened there. But that's typically how you would address that anti-pattern of the distributed monolith. How about some not so technical anti-patterns? These are the non-technical obstacles to achieving success in your journey from monolithic architecture to microservice architecture. The magic pixie dust anti-pattern, and that's basically the belief that if you sprinkle a few microservices around here or there, it's going to solve all your development woes, and that's just not true. What ends up happening is the problems get worse and there's disillusionment. This also relates a little bit to the flying before you walk anti-pattern, which I'll talk about. The solution, you got to identify the core problems in your application and software. Moving to a different architectural approach like microservices doesn't eliminate, for example, your slow siloed manual development and testing and deployment processes. Architecture isn't going to solve that. DevOps will solve that. More small autonomous teams, automated deployment pipelines, that's what'll solve that. Sticky code. If you've got a problem with that code, you have to code better. You have to enforce quality controls on code. We use SonarQube is one of our quality control tools in our code bases. Duplicate code bases. You have to combine and design extension points when you have those problems. And then applications that are just big balls of mud, like they have to be re-architected, maybe to microservices. So sprinkling a few microservices here or there will not solve your software development problems in their entirety. So that's an anti-pattern to watch out for. Another anti-pattern is microservices as the goal. I'm sure you guys this would have been perfect for a Dilbert cartoon. Leadership comes in and they announce this microservice transformation initiative. That's the new buzzword, micro apps, microservices. That's the new big thing. And that becomes the goal. So basically it ignores all the other obstacles. You still end up with processes that are like waterfall, manual testing, manual deployment. Organizationally, you still have siloed teams. Software is still a big ball of mud, stinky code, and teams don't really understand the goal. What ends up happening, that's really what's going on. So a solution to that is, a better goal is, rather than make microservices or micro apps the goal, a better goal is rapid, frequent, reliable software delivery. Make that the goal, and then let the application teams decide how to improve the metrics to achieve that goal. And I showed the metrics at the very beginning when I showed those slides around how we measure velocity, how we measure reliability. Let the teams, do that. So rethink the goal, I guess, is the advice there on that anti-pattern. Scattershot adoption, where you've got multiple teams, everybody goes off on their own, trying to adopt microservices with no coordination whatsoever. Maybe it's because senior management and leadership made microservices the goal, so everybody's off trying to do their own thing. The consequences for that are there's a lot of duplication of effort. Teams don't have the skills to build the infrastructure that they need, because there's infrastructure that's required around this new microservices world. So it's got its issues. It's a general principles, general guidance around avoiding scattershot is it's a five-step process to adoption. Okay, 1, declare and communicate the whole strategy to begin with your teams. Create an infrastructure team so that you're not duplicating infrastructure across the various teams. Select your candidate for your monolith, and then strangle it. So what does that mean? It means define the services, document and share around it, refine the infrastructure, and then cycle until you strangle that monolith. And then after you're done, expand to other applications and continue to evolve your solution there. So scattershot adoption is an anti-pattern that a lot have fallen into. Flying before you walk. So attempting to go into this re-architecting world of microservices where you're really lacking the fundamentals, the key skills. Obviously it's going to lead to disappointment, and because you're not addressing fundamentally what ails you, problems are going to remain or they get worse. So what are clean skills? I mean, things like ability to design in an object-oriented manner, clean code, automated testing, DevOps. There's so many ways to describe it. But if we were to, instead of just going straight to fly, let's start with crawl, clean up your code, introduce, best practices and tooling around quality code management. Like I said, we have SonarQube, we have hundreds of rules that scan code and commitments before and when developers are committing and doing what they need to do. So that's your crawling. Your walking is automated testing. I don't know, easier said than done, but the ability to test in an automated manner is pretty fundamental and crucial to the successful evolution towards reliable and high velocity delivery of quality software. Automated testing is essential. That's walking before you can even fly. Object-oriented design, it sounds obvious, but you'd be surprised how often it's not used where it could. Having domain-driven teams and groups and domain-driven thinking, that starts to take you closer to the direction you need to go, which is ultimately flying, where you're basically deploying to the cloud. You've got DevOps teams, and your architecture is microservices. So before you get there, there are things that you may need to work on and clean up, and sometimes you can do them along the way in process, but they're essential. They're critical. You'll never be able to truly fly without addressing those fundamentals. This is something that happens a lot. Falling in love and being enamored with the technology itself. There's lots of cool technology out there. There are all these vendors, and they're all trying to telling you to buy their cool stuff. They're all selling you this really cool stuff, and their marketing teams are great at making their stuff look amazing, and it makes it look like they will solve all your problems. They're usually very infrastructure related, and they're not application architecture related. So they may help you. They're not going to really solve your problems, and they require a lot of big upfront investment. And it's going to be heavy lifting across the board. There's no specialization. Just focus on the essence of the microservice. So focus on the decomposition exercise itself, and build just enough infrastructure for what you need. Avoid buying until you know what you need to get it done, and don't fall into the trap of just focusing on the technology. This one's the one I want to conclude with. It's one of my favorites because it really summarizes, everything that we talked about, but also it speaks to, it speaks to something that is just funny about human nature. So the red flag law anti-pattern. So back in, early 19th century in the United Kingdom, there were, so early 19th century, so they just invented, cars were just, the automobile was just coming about, and they just invented, and so Parliament was concerned about, because there were a lot of accidents, and they were concerned about safety, and nobody knew what to do with these strange, they had horses on the roads, and that's all people knew, and so they introduced these, passed these acts called the red flag laws. And basically what they did is they regulated the use of these like mechanically propelled devices like cars, on the British public highways, when they were to be used to help to address this problem. And what it required a man to walk in front of the car with a red flag, to warn other vehicles and pedestrians, and to just sort of regulate the car to avoid accidents and whatnot. And it's comic, really, because it defeats the entire purpose of why the car was created to begin with. But they were trying to solve a problem, which was they didn't have the infrastructure to support the automobile. The public's knowledge or understanding of how to coexist with the automobile, so much was missing. And so they introduced these red flag laws to just reduce the accidents, and that's just not the approach. You don't have a guy walking around with a flag in front of the car. The car is basically moving at the same speed as the guy. It just defeats the whole point of it. But that's what the red flag laws are. And some examples of red flag laws and how it relates to software are siloed teams. That's your guy with a red flag walking in front of your car. Manual testing, that's your guy walking with a red flag in front of a car on a road. A model where you're deploying monthly at midnight. All of these are anti-patterns, or are part of the red flag law anti-pattern that you have to address. So the solution to that is understanding that micro apps, microservices are an architectural pattern. They ultimately, they can help you improving your testability and deployability, but then you have to change your processes. You have to have a DevOps team. Just re-architecting alone isn't going to solve it. And you have to have DevOps processes, which is, pipelines and autonomous deployment. Microservice architecture, it will enable autonomy, but organizationally, you have to reorganize yourself into small autonomous teams, or you're not going to solve the true issue at hand. And so microservices, microarchitecture, what we've learned, as we evolved, and it's been a long evolutionary process, is that it's not just hiring smart people to re-architect your solution. It's organizationally from the top down. You have to think differently when you move in that direction. But that ultimately is what will carry you towards having the ability to rapidly and frequently deliver reliable code to your customers. And I think that's my last slide. I had a slide in here about, some of our services. I mean, just to give you guys a sense of how do I encapsulate 1.5 million lines of code into a bunch of visual boxes. But this is, this is what our software does. License management, entity management, enforcement and compliance, inspections and examinations, the administration side of it, which is the configuration side of it, because so much of what we do is driven by configuration, and it's usually UI driven configuration. So there's like this big administrative side to it. And so I would say we're well on our way in our journey, in our evolution. I would say that we probably have more that we could break down and break up into even more and smaller parts and pieces. And I think we're as we start to take it apart and learn and discover that, we're learning more about where we can break it and get even more granular. And I think that's ultimately where things are headed. So the concept itself is not new. I think the evolution takes its time, but the takeaway really is it's not just an evolution of software architecture. It's an evolution of your organization and your processes as well to match with it. So that's my presentation. Happy to answer any questions or share war stories or horror stories of our evolution, or talk more about our regulatory stack if you got any.
Hi, this is Ying, and I'm going to kind of moderate the questions and answers with a bit of a dialogue with Mo at the same time. If I may ask this question, the architecture that you described here, are there specific consideration when you deploy in cloud?
Yeah. So with cloud deployment, we're moving towards a more Kubernetes based approach to how we do our deployment. But the key is to whatever you decide ultimately and how you use it, the key really is to automate your pipelines. Is to build those pipelines, to get those build pipelines and those deployment pipelines as automated as much as possible. Kubernetes is great. We're having good success with it. A lot of the cloud providers have their own tools as well that augment that. I think they're all good, but when you're doing it, just measure yourself with those. Where was that slide? Pull that slide up. Whatever it is you decide to do, be objective in how you measure how well you're getting there. So I can have it here at the very beginning. Right here, yeah.
Yes. In your work with the different states, are there kind of specific examples or types of licensing system where you find, aspects of working with cloud-based technology is more challenging than in other implementations?
The biggest challenge we've had with cloud-based technology is in the ability of our customers to embrace them, believe it or not. There are states where, I don't want to name and shame states, so I'm not going to call them out by name, but there are states where we operate where the state itself has not embraced cloud. And so they're very reluctant to evolve with us, because what's happening now is our software stack is getting to the point where the complexity of having it deployed and managed in-house by a state agency is going to make it unattainable for them to use it. Like, it's truly evolving in a manner where we have to manage to deploy it in our own cloud. And so what's happening is the states where they're not able to address, states have fair and legitimate security concerns about the cloud, obviously. I think those security concerns also apply to in-house data centers as well. So it's just a question of, coming to terms with the inevitable, which is everything is moving to the cloud. And not all states are moving at the same pace in that direction. I think that's been the biggest challenge we have, is dealing with states that are not as progressive about accepting the cloud. Now they're decreasing, they're fewer, but they exist. And not all states are moving at the same speed. And the rigor around security overhead varies also from state to state, and how mature they are in going through the security plans with us and what we do and how we do it with the cloud. But I would say those are the biggest challenges we have with it, not in the cloud itself, like the cloud, the evolution of our software stack and our ability to just spin up our solutions in the cloud has taken our ability to build and deliver to much faster rates.
I have a question here regarding that one slide that you have on the California deployment with some very impressive statistics. Can you talk about the kind of the infrastructure that's used there?
Yeah, so California is one of this implementation, they went live, it's been a while. So these guys went live early on in our journey towards cloud adoption. So we deployed this solution in their data center. So how many nodes do they have? I can't tell you off the top of my head for this one. I can talk to you about the IRS. We have, because I'm a little more familiar with theirs. So they during peak, that system basically regulates the people who are allowed to file your taxes on your behalf. The IRS regulates them. That's actually the only federal agency that regulates a profession, actually. Just interesting fact there. So they use our software, and they during peak renewal, they're hitting millions, and it's all happening in days. And I think they've got it running, how many nodes? I think they've got something like 20 nodes horizontally scaled to meet that demand. I don't think California is as large as them, but I think California probably is just under 10 nodes sitting behind a load balancer. They've got the batch scheduler, sort of its own separate nodes. So it's a multi-node architecture behind a load balancer.
And this IRS implementation you're talking about is in the federal government's data system environment? Yeah,
Accenture runs it for them. Again, I think that's one of the areas where that is evolving. At the time we delivered that solution, again, also it was very early days in cloud, and federal government was not, there was no GovCloud, there was no FedRAMP, all that stuff still hadn't evolved yet. But I think that as this solution evolves for this particular customer, I do see this moving towards a cloud-based offering. Yeah.
Is there a specific cloud-based deployment of a licensing agency or department in your portfolio that you can talk a little bit about?
Yeah, I would say that one of the early adopters was, believe it or not, was from Texas. We moved their agency to the cloud, and the reason they wanted to move towards the cloud was because they wanted one throat to choke. What was happening was a feature would come out, or we'd have a patch, or something would happen. We'd deploy it, we'd give them a code drop, and the agency would have to deal with the state's IT department, and the state's IT department internally would have to figure out how they're managing the code deployment. And then something would go amiss with the code deployment because it wasn't as automated, because it was manually going through all these steps, and something would go wrong, and then it wouldn't solve the problem. And then it'd be a question of, okay, everyone's pointing fingers and who's doing what. And I think the biggest impetus for them is they wanted one throat to choke. And so when we took it over, we put it in AWS. It was one of our first AWS installs. And we brought in our automated pipeline and our build tools and whatnot, because we controlled it from start to finish, the whole deployment process. It was the Department of State Health Services. So they regulate, facilities and healthcare professionals and whatnot in Texas. I think that was one of our very first ones. We've got a few that are in the cloud, but we've been operating them pretty successfully, I'd say, for more than 5 years in AWS. So.
Great. We have a question coming in from the chat line that has to do with in the implementation in state government regulatory agencies. Are there a situation where the state's policies or quality and security related procedures and processes hamper your deployment, or otherwise make it difficult for deploying using a specific approach that you have designed and engineered?
I would say that I can't name names. I'm not going to name and shame states. We do have, there's one state where we're dealing with where we are going through a lot of rigor around our cloud-based architecture solution, and the validation of our documentation, and we're getting a lot of questions, and there's a lot of meetings resulting from it, which is definitely, I would say, it's slowing the implementation down. And I don't know if that's because their state, and it's a different group. It's the state IT department, actually, not the regulatory agency. I don't know if it's because state IT departments are still coming to grips with this new reality of cloud, and probably because there's an immaturity in the certification levels of cloud. So now a lot of people are rallying around FedRAMP, StateRAMP. So if you can go in and say, yeah, we're FedRAMP, and we've got, an ATO for FedRAMP, and our software runs, in this, I think eventually a lot more IT departments will embrace that and accept it. But what's happening is states are coming up, I guess it's because they don't want to follow whatever the federal government's doing. So they're coming up with their own thing called StateRAMP, which is, I guess, an offshoot. It takes from FedRAMP, but then each group of states get to make it their own. States want to make everything their own, right? But I think once we start to get a more unified acceptance of things like FedRAMP and whatnot, maybe those problems will go away. But yeah, we do have an implementation where there's just more rigor than I think. It's creating more meetings and documentation and overhead than I think is of value ultimately to the taxpayer, because that's ultimately who these agencies are serving. But I not all of them, but it happens. Yeah, it does happen.
Yes, we have a question from our program chair. He's going to come up and
ask a good question. Well, my question is rather generic in the terms of how do you really approach the quality? You have a monolithic, and you really want to take that and change that into web services. What kind of things or precautions or guidance would you take to make sure that you have at least the quality of monolithic, if not better?
Yeah, it's a good question. So I would say that for starters, do never underestimate the power of domain knowledge, whether it's monolithic or microservices, whatever it is. That's invaluable. Our quality people who are immersed in the problem that the software solves, rather than the software itself, are the most successful quality people that we have. So I think fundamentally, it's just never underestimate the importance of understanding the domain and appreciating the domain. When you move to a microservice architectural approach and you start to reorganize your teams, it gives you a chance now to allow them to be more focused on that domain in which they operate. So I think that in and of itself, if you can achieve that undertaking, and that's already a very big undertaking, you will already start to see quality code improvement because you're getting that focused on the domain. But I think the second most important thing about microservices that we didn't do as much with the monolith, but that it's essential is automation. I think where you can automate quality control checks as much as possible is the more you can do that, the more success you'll have, because ultimately it is about ability to deploy very, very quickly. And so you can't really be stuck in the mindset of manual testing. Manual testing will never entirely completely go away. But you can't be stuck in that mindset for a lot of what you do. And so when you start to break it down into smaller parts and pieces, and you start to think about how I can automate it better and come up with better quality control type checks, you'll see actually in the long term, microservices will help you achieve higher quality because they will force you to do that, because otherwise you're not. Otherwise, it's the red flag. You've got a car and it's moving at the speed of the guy walking in front of it with a red flag. So.
I have a question on behalf of the PNSQC community. Many of them work with agile development methodology. I'm just wondering to what extent your shop utilize agile methodology.
Oh yeah, no, we're all over agile. I think actually, we've got Scrum teams. I think I had a slide where these are our actual Scrum teams. Actually, that slide I had right here. These are 3 of our sprint teams. We have small teams. They're about 5 people per sprint team that will that we've and it didn't start that way. It started off first as when we introduced agile methodology and agile teams and Scrum to our development methodology. We were not targeting them towards domain specific areas of responsibility. This is part of our evolution. Like those slides I talked about, the patterns and anti-patterns, like we lived it. At first, we were just trying to get better at reorganizing ourselves and working with this methodology, and moving away from the waterfall methodology. So internally, Agile has worked very well for us. It's made us very nimble, and it's certainly helped us evolve with our evolving architecture. Where it's been a challenge, I find, has been in when we go out, win a deal, and it's usually a fixed cost contract with a particular agency, and we want to introduce Agile to the way we deliver it. Marrying Agile to delivery to actual customers of our solution, which is more than just delivering the software. You have to deliver the software, you have to configure it, you have to user acceptance testing, has required a little bit more of a marriage between traditional waterfall and agile. But internally, product development, our roadmap, how we manage our product evolution to our CapEx budget, agile has been working very well. So,
in the last minute, I'd like to ask you a real quick question about the use of GovCloud versus commercial cloud, because that often come up in state government context.
This ultimately comes down to what the agency is comfortable with. So I suspect when we go and eventually get to upgrading the IRS, they may, and they show interest in cloud, I suspect they may have, they may insist on GovCloud. They may have FedRAMP, rather than FedRAMP moderate expectations, FedRAMP high expectations. And so it really comes to the agency and the agency's expectations around what kind of security they need. for what kind of data they're managing. Not everybody needs GovCloud. But if your agency deals with particular types of data or has security concerns that predicate it, then that's what will drive it. For us, it makes from our architecture, technology, and our ability to deploy the solution, it makes no difference. We treat the cloud like the cloud. It's ultimately just which cloud you're deploying to.
Thank you, Mo. I'm going to have our program chair make some.
There's one more question.
Oh, okay. Please read it.
Hey Mo, we got a question in the chat. They ask any advice or specific challenge to be aware of upgrading from a dated system to a modern one with various micro-solution modules/features, specifically when it comes to functionality, crosswalks for current processes.
Yeah. Yeah, pay a lot of attention to the phase of your design where you are trying to determine how to break it up into microservices, because you know, when I talked about strangling the monolith, spend the time on that. It will take its time. Put the time into determining what to break up and how before actually going off and starting to build it. So for us, it was pretty straightforward in many ways. You know, when I showed the diagrams, we had licensing and cache and enforcement, because we already were thinking that way. Even within the monolith, we were thinking that way. And I'm sure you are too, where whatever your dated legacy system is, I'm sure you've already got some of those modules and those patterns. Start with that, but definitely try to adhere to the encapsulation principles and isolation principles of building a micro app. Try and have those interfaces as minimal as possible, but spend the time in the design. It would be my advice, definitely.
All right. Well, let's give a big hand to Mo for his presentation.
Thanks, guys. I appreciate it.
I'd like to emphasize the fact that we have extended the proposal submission deadline to May 9th. So bring your experiences, share with others, and we'll help you out with whatever you need in delivering a presentation. It's a great opportunity. I've done it about 24 times, and every time I do it, it's a thrill. Okay? So keep that in mind. And our conference is October 10th through 12th. And I also want to thank again NIC and Tyler for sponsoring this event, and we look forward to our longer cooperation in the future for these kind of events. Thank you everyone for attending. The talk would be online in a few days or so. Yeah, and join us again for our next meet in May. Thanks again. Bye, everyone.
Bye-bye.